What's a service? Hello.
Hello, Doc.
Yeah, please can you see my screen?
No, please.
I'm sharing my screen too.
It's not coming.
January.
Please can you see it now?
Yes.
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 So as I said, the course code is MAT102D, and the title is Analytic Geometry and Calculus. And as I said yesterday, the prerequisites for this course is elective maths plus core mathematics. So today, by the end of this, what we're going to do today, you should be able to demonstrate knowledge in Cartesian coordinate system. You should be able to find distance of line segments, gradients, and then dividing line segment into ratio. So that's what we're going to do today. So the outline of the presentation will look at the formula for distance between 2 points. So when you have 2 points, point A and then point B, how do we find the distance? It's
Madam.
unfortunate. Hello.
Very good morning.
Yeah, good morning.
Please, I think if you can make your phone turn into landscape.
Okay, let me do that.
Okay.
You will do it. Try. This.
Most of us with background noise. Can we read it?
There's noise, eh?
Yes, please. Some of us have not muted our mic, and then there are noise background, so we can all mute to hear Doc.
Okay. It's unfortunate. I don't know. I'm not able to rotate. Let me see. This is my new phone. I don't know how to do it. Let me see. If my
Oh, madam,
small
let's
girl.
move on.
You should move on. Okay, so I think it's on now. Let me see if it's all okay. Is it okay now?
Yes, please.
Yes,
Yes.
Doc.
Okay.
Yes.
Okay, so as I said, we'll be looking at the formula for distance between 2 points A and B. So when you have a straight line, we have a point A and then point B. We want to find the distance from the point A to the point B. So look at how to find the distance, the formula for the distance between the two. And then also the angle between 2 points. Okay, 2 lines. So when you have 2 lines, how do you find the distance between the 2 lines? And then we also look at division of a line segment. Okay, in a given ratio. So in the ratio, we'll look at equal midpoints when we divide the line equally, and then also dividing it into a given ratio. We also look at how to find the gradient of a line, and then also how to find equation of a line. And as I said yesterday, I said that most of the things that you're going to do here are the same thing that you know from SHS, JHS, and wherever you've heard it. So please don't see it as something different or something that you don't know, please. Okay, because I know that we all know how to find gradients. Do we know how to find gradients of a line?
Yes, please.
So given 2 points A and B, how do you find the gradients? So let's assume the point A has the A has coordinates x1, y1, and then B has coordinates x2 and y2. How do you find the gradients? Hello.
Y2 minus Y1 out of
Y2 minus
X2
Y1.
minus X1.
So
Yeah.
it's the same thing that you're going to do. And how do you find the equation of a line?
Y minus Y1 equals bracket equals M bracket open X minus X1.
Thank you very much. So it's the same thing. So as I said, it's the same thing that you know. So let's continue. Let's start. So we are looking at the coordinate geometry. So we are saying that point on a line, when you say a line, each point on a line can be identified. Hey, where I am is too noisy. Let me see if I can get to a place where it's up. It's okay. Hello. Hello. Yeah, can you hear me?
Yes,
Yes.
please.
Okay. So let's continue. So as I was saying, I said that when you look at the coordinate system,
Madam, the screen is off.
the screen is off.
Yes, please.
Yes, madam.
Is it on now?
No, madam.
No, madam.
Is it on now?
No, please.
No,
Hey,
please.
what is happening? Share my screen. Is it on now?
Yes, please. It's showing now.
Yes, madam.
Okay. So as I was saying, I said that points on a line can be identified with real numbers to form the coordinate line. Similarly, points on plane can be identified with ordered pair of numbers to form the coordinate plane. So when we take the plane, each points can be identified with an ordered pair. When we talk about order, it means that suppose I have a point x1. So the example I asked you, I have a point x1 and then x2. Okay. So when I have x1 and then y1, it means that my x1 is on the x-axis and then the y1 is on the y-axis. When I turn it and then I write y1 x1, it still means that this one means that my y1 is on the x-axis and then my x1 is on the y-axis. The order is very important. So when you see maybe 1 2, it means that the 1 is on the x-axis and then the 2 is on the y-axis. When you see 2 1, still my 2 is on the x-axis and then my 1 is on the y-axis. So that's what I said, it is an ordered pair. For instance, any point P in the coordinate plane can be located by a unique ordered pair of numbers, A, B. The first number A is referred to as the x coordinate of P, and the second number B is also referred to as the y coordinate of P. I hope you understand it. So if I have the point A, B, my A is for the x axis, and then my B is for the y axis. So example, I want to find the distance between the point A and B. So I have a point A and B. Please, can you see this point A and B? There's a straight line. And then at the end of the point, we have A and B. Please, can you see it?
Yes, madam.
Yes, madam. Yes, we can see.
Okay. Now, if I decide to join it by forming a triangle, I would draw a line from A to meet C, and then from C, and then from C to join to meet B. So I hope you can see the right angle triangle over there.
Yes,
Can you
madam.
see it? Okay.
Yes, madam.
I hope I can write it. By my laptop is off, as I said. So please just try and follow. With time I'll go for my laptop. Okay. Now when I take the down part of the triangle, the point from the point A to the point C, we can see that is still on the x-axis. So the length from A to C for that one is giving us x2 minus x1. Can you say it?
Yes,
Between
madam.
A and C.
Yes,
Okay.
madam. Yes, we can see.
And then between C and B, that distance there is y2 minus y1. Now, to help us find the distance from A to B, Pythagoras gives us a formula, and it says that to find the distance from A to C, we can write it as the distance from A to B squared is equal to the distance from A to C squared plus the distance from C to B squared. So I don't know if you remember Pythagoras theory that A squared is equal to B squared minus A squared. Please, you remember that?
Yes, madam.
Yes, madam.
Uh-huh.
Yeah.
So if we repeat that, the same thing, then we have our, can you see that this D of A comma B squared is equal to absolute of AC squared plus absolute of BC squared? And we know that our AC is x2 minus x1. So in place of absolute AC squared, I'll write x2 minus x1 squared, then plus my BC squared, I'll write it as y squared, y2 minus y1 squared. Now I want to find distance AB. So I have to find square root on both sides to take care of the square. I hope you can see the red circle over there. Please, can you see that I've circled
Yes,
something?
Yes, madam.
Okay. So want to find D of A comma B. So to take care of the squared over there, I have to square both sides. Now, when you square both sides, you're going to get D of A comma B is equal to square root of x squared my square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the distance, formula of the distance between A and then B. So anytime you are given a point, you're given 2 points, and you want to find the distance between the two, it is given as y2 minus y1, x2 minus x1 squared plus y2 minus y1 squared. So for example, let's see. I wish I can. Okay. So example, we are given 2 points. It says that which of the points P and the coordinate of P is -1, -2, and another one Q, and it has coordinates 8 and 9. And we want to find out which of the two is closer to the point A. So this means that I can draw a point A. Let me see if I can get something to write on. Wish I can write on this. So let me see. Okay, let me see. I have a pen here. Pen here. Okay, so here we are given. I wish I can get a plain sheet so that I write on it. It's noisy. I'm not in the house. So notes. If I'm in the house, I will just go for. Okay. So here we are given point P, and P has coordinates. So P has coordinates -1, -2. And then we are given point Q, and Q has coordinates 8 and 9. So let me just choose this. And then we have the point A, and the A has coordinates. Let me go back. A has coordinates. What is the coordinate for A?
3,5.
3,5.
A, 5. A is 3,5. Okay. Okay, so A is 3,5. Okay, so when we draw this, so we have our A. Okay, so let me draw the XY plane. I have my plane here, and my A is 3,5. So let's assume 3,5 is here. I have 3 and then 5 here. And then my P is -1, -2. So -1 is here, -2 is somewhere here. -2 is here, -1 is here. So we have -2, -1. And then let's assume we have 8, 9. So my 8 will be somewhere here, and maybe my 9 will be here. So that point is also here. So that's my Q, this is my A, and then this is my P. Now I want to find out if P is closer to A than Q. So we want to find out which of the two is closer to A, either P or Q. So in this case, it means that I want to find the distance from P to A and then from Q to A, then I'll compare. So let's do that. So let's find the distance. So let's first of all find AP. So AP, we know AP from the formula is square root of, so I can pick my x2 to be 3. So I have 3, then minus 1. Minus 1 is 1 squared plus, then I have 5 minus 2, that is plus 2. So that's the square root of 4 plus 1, 3 plus 1 is 4. So 4 squared is 16, right?
Yes, madam.
Then plus the other one is 5 plus 2. 5 plus 2 is what? 7. 7
So
squared is what?
49.
49. Okay. So 49 plus 16 is what?
65.
So square root of 65. So that is my AP. So my AP is 65. Let me clear this one and write it. Then I can. So the distance AP is equal to root of 65. Now let's find the distance between A and Q. Okay. So my A and Q, that is the distance between A and Q. So that is square root of, so it's square root of, okay, so I can write any of them to be, so I have 8.
Hello, madam.
Hello.
I was like, I don't know if it's peculiar to my side. I can hardly see the screen and the way the whole thing is going. I don't know if somebody is also seeing the same. No, the screen is there, but it's like
I'm having the same challenge here. I'm having the same challenge here.
But some of us can also see it clearly.
So maybe it's your network. So please check that for me. So we have 8 minus 3. 8 minus 3 squared plus 9 minus 5 squared. So 8 minus 3 squared is what? So 8 minus 3 is 5. 5 squared is 25.
3 minus 8.
Okay, so whether you write 3 minus 8 or 8 minus 3, it's going to be negative 5 squared is 25.
Very well.
So you decide which of them to be your equation.
Noted.
Okay. Okay, so 9 minus 5 is what?
4.
4. So 4 squared is
16.
16. Okay, so 16 plus 25 is
41.
okay. So the distance between A and Q is square root of root 41. 41. So we want to find out if Q is closer to A or P is closer to A by comparing the distance. One is root 65, one is root 41. So which one is bigger? The two, which one is bigger?
The root 65 is the bigger one.
So what does that mean? Which one is closer?
For me, I think the second one is closer to A than the first one.
Because the distance is shorter or smaller, right?
Yeah.
Okay. So it means that my Q is closer to A than my P. Okay, so to find out which of them is closer, you can find the distance between that point to A and then from A to that point. Is there a hand up? What's
Yes,
in your
madam.
hand is
Yeah, please. I want to ask, what if the distances are the same?
So it means that
They are
then you
the
conclude
distances
that
are
the
equal.
distance is equal. Yeah. So you just conclude that it's the same distance. Are you okay?
Yeah, I'm okay.
Okay. Dominic, your hand is up.
Madam, please, let's go back to the diagram.
The one I did or the one on the board on in the notes?
In the note.
Okay. Please, I'm coming. Let me clean this. Okay, Dominic, we are here.
Not this diagram, the first one. The right angle triangle you wrote.
Okay.
This one.
Mm-hmm.
For the A, we have the A coordinates to be S1 minus Y1.
Okay.
Then S2 minus Y1. Then why the B be S2 minus Y2?
Please come again.
At the B, the coordinates of B.
Coordinate of B. Coordinate of B is x2, y2.
I don't understand why we have S2, Y1, S1, Y1, and instead of
What
why
is
not
x? What is x2, y1? The coordinates
A?
of A. The coordinates of A is x1, y1, and the coordinates of B is x2, y2. Are you
That's
okay?
why I don't.
That's what you don't understand. Hello,
Or
Dominic.
they will give you the coordinates just like that.
Yeah, they gave you the coordinates. X1 and then X2 are just constant. They are just something that we are using to represent something. So for the example, you see that we're giving P to have coordinates -1, -2, and then Q to be 8 and 9. So they are the X1, X2. So it's just some variable to represent something.
Thank you, madam.
But I wanted us to, because we chose X1,
So,
X2
madam,
because
does it mean that the X values, you have to choose the one you want it to become your X1 or X2? That
is
one
it from
depends on you.
is it for the proof or for what?
In solving,
Yeah. Because it is square roots. Because you will square it. Because you will square it. If you choose any of them to be your X1 or X2, you're going to get the same answer. So you will choose which
okay.
of them will be your X1 or X2. But mostly your X1 should be, you see, when you draw the XY plane, the one that will come down like the smallest, like when you choose A and B, you can see the values for A are the small values. They are the small values. So you choose them to be your X1, X2. But you can decide to make any of them to be your X1 or X2. It's the same. You're going to get the same answer. But we know that one comes before two. That's why we always associate the one to the smaller ones or the initial point, and then the two to the terminal points. Are you okay?
Yes, madam.
Okay. So since the distance between Q and A is less than the distance between P and A, we conclude that Q is closer to A. So that's one example. You can look for different examples, how to find distance. You can turn it around, do so many things with it. Okay, so this is about distance, and what we want to do right now is how to apply the distance formula. So we've been able to apply it here. You can look for more questions on how to apply the distance formula. So the next I want to move on to how to find the
Hello,
line
Doc.
segment. Hello.
Doc, this Isa.
Okay.
Doc, I understood you very well, but we have different lectures altogether.
Okay.
In the exams hall, I happen to give out the formula very well, which has to do with x2 minus x1, y2 minus y2. Then in the
What
course
x2 minus x1,
yes, plus
plus
y2 minus
y2 minus
y1.
y1.
Yes, root of. So in the course of what is the name? Substituting the
values.
values.
Mm-hmm.
Then happens to as you said, use any of the distance that I prefer to.
Okay. So if you are choosing, so let's assume we are using this equation, the question. If
Yes.
I want to make my p value, the coordinate of p, x, the -1, to be my x2, then you make sure that -2 will be your y2.
Very
Do
well.
you understand?
Very well. Yes.
Then
Yes.
if you choose the coordinate of q to be your 8 to be your x1, then it means that your your y1 is supposed to be 9.
Okay.
So
Because that's what I'm saying.
can't choose you can't make p1 for p x1 to be your -1 to be your x1 and the -2 will be your y2. You can't do that.
Madam, what I'm saying is looking at the substitution that you did in the equation, 3 minus 1 all squared. So if I happen to say
-1 minus 3,
minus,
you're going to get -1 minus 3, which is -4.
Yes,
-4
all
squared is still 16.
Yes. So in that case, no, like because we mark according to the steps and not the answer.
Who marked that?
Hey, madam, you lecturers.
Oh no, it's not true.
Very well noted.
This is not true.
Very
One,
well.
this is not true. 2, we have only one coordinator, so the coordinator will bring her marking scheme, and it's the coordinator's marking scheme that we're going to use. And the coordinator knows that whether you choose just to be your x1 or x2, you arrive at the same answer. So the coordinator will choose lecturers who understand the concept to mark the scripts. Are you okay?
Yes, Doc. Thank you very much.
You're welcome. Let's continue. Is there a hand up? Mohammed?
Yes, but yes, choosing the coordinates, one being x1 or one being y1, does not have a problem with the answer. Is that it?
Yeah, it will not have effect on the answer.
Yeah. Okay. Thank you, brother.
Yes. Welcome. But at least when you sketch it, you will see which of them should be your x1 and x2. But when you don't sketch it and you are just plotting it, you can choose any of them to be your x1 and x2. It's the same thing. Okay, let's continue. So now we know how to apply the distance formula. The next thing, I want to look at midpoints of a line segment. So if I have a line with endpoints A and B, we want midpoints. We understand midpoints. We want to find when we divide that line equally, the middle, the point there. We want to find the coordinates of that point that divides the line equally. Okay. I wish I can write. Okay. So we have it here. My point A has coordinates x1, y1. My point B has coordinates x2, y2. Now I want to find the midpoint. The midpoint is denoted by m. Okay. So if I pick my m and then I bring it down, and then to meet that straight line that joins A, I can call that point P. Can you say it?
Yes, Doc.
So if I call that point P, we can get the coordinates for P. So on the x-axis, I can see that on the x-axis, the points or the s-coordinates for P is the same as the s-coordinates for my M. Can you say it?
Yeah.
Okay, so when I come here, you will see that when I come here, why is this thing not going? The point here, when I draw it down, when I draw it to the x-axis, you see that the point, can you also see that marker thing? It should go, it's not going.
No, madam.
This marker should go. There's a marker on my screen, it's not going.
Madam, please continue.
Okay, I'll continue. Okay, so this point here, the point P will have coordinates x and then y1. Then when I come to the B, I draw a line from B to meet where my M coordinates are. I call it Q, and this will have coordinates S2 and then Y. I wish I can write on my board. No problem, we can continue. Now to find the midpoints, we can see that the distance, I said it is midpoint. So since it is midpoint, then it means that the distance from A to P is the same as the distance from M to Q. It's a midpoint. So the distance from A to P will be the same as the distance from M to Q. So the distance, and then we can see that the distance from A to P, that is on the x-axis, and it's going to be x minus x1. Please, can you say it?
Yes, please.
So the distance here, it is the biggest minus smallest. So this is on the x-axis. So it is x minus x1. And then the distance on this place too, the distance on this here, it's also x2 minus x1, because I said they are midpoint, so the distance are the same. So the distance from A to P, which is x minus x1, is equal to the distance from M to P, which is x2 minus x. So that is what we have. X minus x1 is equal to x2 minus x. Then we are just grouping the x. We want to make x the subject. So group the x value. So going to get 2x is equal to x2 plus x1. Then we are making x the subject, as I said. So I have to divide through by x. And I'm going to get my x to be x2 plus x1, all divided by 2. That is for my x coordinates. Then the next thing, I have to find my y coordinates. So I've seen that this midpoint from my A to P is the same as my M to Q. Then my P to M is a midpoint. So my P to M, the distance from P to M is the same as the distance from Q to B. So that means that my coordinate over there is going to be y minus y1, and it's going to be the same as y2 minus y. So that is from Q to B. Okay. So I'm going to get y minus y1 is equal to y2 minus y. Then I make y the subject. So when I rearrange this, I'm going to get 2y is equal to y2 plus y. I divide through by 2, which is 2y is equal to y2 plus y1. I divide through by 2, and my y is going to be y2 plus y1 over 2. In the diagram, I have the coordinate of M. My M is the point, the midpoint. So in place of x comma y, I know that my x is x2 plus x1 divided by 2, and my y is y2 plus y1 divided by 2. So in place of x and y, I'll write x2 plus y1 divided by 2 and y2 plus y1 divided by 2. And that is my coordinates for x1, for x. That's the coordinates for my midpoints. Please, are you okay? Hello?
Yes, madam. Madam, we are okay.
Okay. So we want to apply that thing here. It says that show that the equilateral with vertices P, Q, R, and S is a parallelogram by proving that its two diagonals bisect each other. Okay. So we want to prove that. So that means that you have to draw this equilateral. So you go to your board. So please write the point for me. Point P, write it down and go to the whiteboard and then ask you for the points. So P is 1, 2, Q is 4, 4, R is 5, 9, and then S is 2, 7. Please write it down for me. Are you done?
Yes, madam.
Yes, madam. Yes.
So let me go to the board. Let me see my notes. Can I use this? Or this? Notes. Okay, so I go to the notes. I think it's a new one. Okay, so there's a new one here. Okay. This one here. Let's see. So I want to draw. So I want to do, I have my XY plane. I have my XY plane. This. I have my XY plane. Let me try and draw the point. Okay, so my point P is, what's the coordinate of P? So I have
P, 1, 2. 1, 2.
Okay, so let me just label my axes. 6, 8, 10. That's my X. And then my Y, let me just write 5, 10, 15. Let me just write it like that. So he said my P is
P, 1, 2.
1, 2.
So let me say 1 is here and then 2 is here. So 1, 2 is here. This is my P. Okay, 1, 2. P is 1, 2. And then what again?
Q, 4, 4.
I have Q. Q is 4, 4. So 4, 4 will be somewhere here. Some wadi date will not be nice cry. It's 4, 4. Okay, so this is my Q. And what again?
R, 5, 9.
R is 5, 9. So let me assume my 5 is here. So 5, 9. 9 is here. 5, 9. R. And what again?
S 27.
This the drawing there will not be nice cry. And then S 2, 7. It's 2 and 7. 2, 7 will be somewhere here. 2, 7. Hey, when I draw this one there, it will not be nice. If it were to be on some board Bianca, it will be very nice, but it looks like a parallelogram. Okay. So I want to show that the diagonals, this
Don't
one, they
worry, not draw
intersect.
to scale.
Not drawn to scale. Okay. So we have something like that. And we want to show that they intersect. So how to find the midpoint from S to Q, and then distance from midpoint from P
To R.
to R, and then show that they have the same coordinates. So that's what we are doing. Okay, so that is the drawing. It is here. When you take your time to draw, you're going to get P, S, Q, and then R like that. Okay, so we want to show that the coordinates for the midpoint between S and then Q is the same as the coordinate for the midpoint between P and then R. So let's find the midpoint. So please find the midpoint between S and then Q for me. You know the coordinates will be x2 plus x1 divided by 2. That is for the S coordinate. And then Y coordinate is y2 plus y1 over 2. So you can choose your x1 to be 4 or maybe 1. So you can have 1 plus 4, which is 6, divided by 2 is 3. And the other one will be 7 plus 2, which is 11, divided by 2. So that is your S coordinates. So you're going to get, so that is the QS, which is 3 and then 11 on 2. Then you can also find the midpoint. So we find the Y coordinate. Y coordinate, as I said, 7 plus 4 over 2. You did that. And then you go to find the midpoint for P and then R. P and R, then you're going to get 1 plus 5, which is 6. 6 divided by 2 is 3. Then you find 9 plus 2, which is 11, divided by 2, which is 11 over 2. So you can see that both of the two, the midpoint, you're going to get 11, 11 on 2. 3, 11 on 2. Please, are you following?
Yes, madam. Yes.
Yes, dog.
Okay. So coordinates, you're going to get the midpoint to be 3, 11 on 2 for both of them. So since we have gotten the same midpoint, it means that the two diagonals, they bisect. So to prove that they bisect, you've seen that we have applied the midpoint formula here. Any question before I continue? Any question?
Dog, for now, no.
For now, no. Okay, I hear. Please let me go back to my car. So give me some few seconds. I'm walking to my car. I think the church has closed. So you can have different questions that you have to apply this method. It's not always that you have to prove that the midpoint intersect. There will be some question, and then you see that this one you have to apply the midpoint method. Okay. And then there will be other questions that you see that you have to apply different the distance method to solve. So please pay attention to that.
Hello, please. I went off, and may I know where we are now? My phone, my network went off, so I just joined back. Mama.
Hello.
Hi, madam.
So please let's continue.
Who the
Battery. Okay, so we are done with the midpoints. Now I want to look at how to find gradients. So the gradients you already know. So the gradient, we consider a triangle ABC with coordinates x1, y1, B with coordinates x2, y2, and then C with coordinates x3, y3. So you can just draw right angle triangle as shown here. And we want to find the angle. We want to find the gradients. When we talk about the gradients, we want to look at the steepness, the slope, Okay. So even this, it's the angle here. So we want to find the angle here. And then from Pythagoras, from our trig, we can see that the angle here, it's, if we say sine, I hope you remember how to find tan sine theta, tan theta, cos theta.
Madam Tua.
So katwa, yeah. Yeah, that is the trig. Okay. So here, where the angle is, we can see the opposite and then the adjacent. Can you see it?
Yes.
Yes, please.
The opposite has the coordinates, and then the adjacent has the coordinates x2 minus x1. Okay. And we know that is tan. So tan is the twa, it's opposite over adjacent. Okay. So to find the steepness, we can use the angle. Tan theta is equal to the opposite over adjacent, and that is the slope. Okay. So my opposite is y2 minus y1 divided by my 2. This is the adjacent, which is x2 minus x1. So that is it. Y2 minus y1 divided by x2 over x1. Okay, so the gradient of the line is given by AB, which is y2 minus y1 over x2 minus x1. Also, since we have a right angle triangle, by using the trig identity, the gradient of AB can be written as AB is equal to tan theta. You know that tan theta, as I just mentioned, it is opposite over adjacent, which is y2 minus y1 divided by x2 minus x1. So that is the gradient. So if you are given any point, 2 points, you should be able to find the angle. Even from the 2 examples that you are given, any example, you should be able to find the gradient. Now the next thing, we want to find, or we should just choose some points and try to find the angle between them. So maybe we can choose the points. So let's choose some points. Let's choose -1, -2, and then 8,9. Let's see if we can find the gradients. Please find the gradients for me. Sorry about that.
$11/10.
11/9.
Madam, please, the gradient is 11 on 9.
Please, what did you get?
11
11/9.
on 9.
11 or 9. Okay. Thank you. So that is the gradient. Thank you. Now the next thing is the relationship between the gradients of lines. The relationship between the gradients of line. So first I want to find relationship between the gradients of parallel lines. The gradients, the relationship between the gradients of parallel lines. Okay. So let two lines L1 and L2 have gradients M1 and M2 respectively. If L1 and L2 are this one, I shouldn't show it to you. You should know this relationship. Do you know this relationship? The relationship between gradient line. Parallel lines.
Yes, madam.
Okay. So if two lines are
Yes, madam.
parallel, what is the relationship?
Madam, the ingredients are
They have the
the
same
ingredients are
ingredient.
the same.
Okay. And if they are perpendicular?
They are perpendicular. The product of the ingredients is equal to -1, or the ingredient of one line is the negative inverse of the other.
Then I'm winning that. Maybe you people are good, Papa. That's what I want to say. He says that so if L1 and L2 are parallel, then my M1 is equal to M2. That is, they have the same gradients. Now, if L1 and L2 are two lines with gradients M1 and M2, then if they're perpendicular, then the product of the two gradients is equal to -1. Or M2 is equal to -1 over M1, or M1 is equal to -1 over M2. You are good. That is it. Okay. Thank you. Now the next one, we want to find the equation. So you know these ones, you know the relationship, but you should know when to apply them. So in the question, so mostly students will complain that, oh, they taught us how to find gradients of a line. They taught us how to find equation of the line. They taught us the relationship between gradients of a line. But in the question, we are given something else. You will not be given something else, but you will have to apply them. So in the question, we will say that two lines are parallel, this and that, then something. So you have to apply these relationships. So it will not be direct that show that this line are parallel or something like that. But in the question, you have to apply them. We'll get there. So by the end, before we end, I will give you one assignment or something that you will try where you will apply all these things. So I want to look at equation of a line. So consider a line through the point x1, A with coordinates x1, y1, with gradient m. And then let the point B with coordinates x, y be another point on the line. So we have it. We have A with coordinates x1, y1, and then B with coordinates x and y. So this one is not x1, y1, it is x and y. Okay, now the gradient of the line, which is the steepness or the slope, is my m. Now to find the equation of the line, we know that the gradient m is equal to y. So the y, you can y minus y1 over x minus x1. That is my gradient. My gradient is y. So since I'm giving two coordinates, so you can see that here I was not giving x2. I was not giving y x2 and then y2, but I was giving x and y. Then I have x1 and then y1. So my gradient is y minus y1 divided by x minus x1. Now, when I cross multiply, I'm going to get y minus y1 is equal to m into bracket x minus x1. You can write it as x2 or just x. You can write it as y2 minus y1 or y minus y1. It's the same thing. Okay. So that is the equation. This is the equation of the straight line. You can just make y the subject so that you have your y is equal to m into bracket x minus x1 plus y1. That is also the equation of the line. So we have an example. We want to find the equation of the line through the point 1, 2 with gradient 5. So here I'm giving the gradients and I want to find the equation of the line. So this means that I have to let another point. You can let that point be any point, maybe the point B on the line. So the B will have the coordinates x1, we will have the coordinates x and y. X and y, so that I can quote
That's me there.
y minus y1 is equal to m into bracket x minus x1. Okay. So here, let x1 be equal to 1, and then y1 be equal to 3, and the gradient m equals to 5. Then, by using that equation up here, then the equation of the line will be y minus 3 is equal to 5 into bracket x minus 1. So I said we want to make y the subject. So my y will be, you expand this one you expand, you're going to get 5x minus 5, then plus 5, which is equal to y is equal to 5x minus 2. That is the equation of the line. So the equation of the line is y is equal to 5x minus 2. Sometimes the equation of the line is expressed in the form y is equal to ms plus c. I hope you've seen this one before.
Yes, madam.
Y is equal to ms plus c.
Yes, madam.
Yes, madam.
Yes.
So in such situation, the gradient m of the line is the coefficient of x. So when the equation is expressed as ms plus c, the coefficient of x is my gradient. And then the c is my y intercept. Please, I'm done with the equation of the line. I'm also done with the relationship between gradients of a line. I'm done with gradients of a line. I'm done with the equation of a line. I'm done with the relationship between gradients. I'm also done with the midpoint of a line segment. I'm done with formula for finding distance. Any questions before I continue?
Yes, I have a question.
You have a question?
Yes, please.
Please ask.
Okay. Assuming you are given the line itself.
By giving the line itself.
Yes. The
What
line
does that
encoded.
mean?
Like in a graph, you are given the line and the coordinate.
Okay.
So
But
can
we're
you
not
use
giving, but we're not giving the slope.
Yes.
Okay,
Not the
so
slope.
it means that you have to find your slope.
Okay.
Using the 2 points. Then
Okay.
after that, you can use any of the line or any of the points to be your x1, y1.
Okay.
And then you have y minus y1 is equal to m into brackets x minus x1. So you can choose any of the point, the 2 points, to be your x1, y1. I hope you're okay. Are you okay?
Yes, madam. Thank you.
You're welcome. So let's continue. The next, I want to find angle between two lines. Angle between two lines. Okay, so please a minute. Hello, let's continue. Okay, so the next we want to look at the relationship between two lines. So consider the lines L1 and L2 with gradients M1 and M2 respectively. Then suppose that the gradient of the first line, that is L1, so the gradient of the first line M1. The first line is L1 and its gradient is M1. So let's suppose that M1 is greater than M2 and both of them are non-negative. They are both greater than 0. Then observe that, okay, so you can draw the line, you can sketch it. So you have the two gradients. But we are told that the gradient of the L1 is greater than the gradient of L2. This means that the L1, when you are climbing the first one, it will be very difficult, more than climbing the second one. So it is the first one, it's steeper than the L1, the line 1 is steeper than the line 2. So look at the graph. The L1 is this one. Climbing this one, the L1 will be difficult. By climbing L2 will be less difficult. So that is it. So it says that
Cassandra, please off your video, your
both of them
camera.
are difficult. Both of them are non-negative. Now, when we look at this graph, we can see that we can find two gradients between them. We can find two gradients between these two. We can find gradients between the two. So we can find gradients here between this and this. And then we find gradients here. So the gradients here is the same as the gradients here. And the angle here is the same as the angle here.
Yeah, vertically opposite angles.
So you remember you learned so many things. So we are applying them. So if I call the angle here, if I call the angle here theta, then I can consider this line L1. Then from somewhere, either JHS or SHS, I was told that the angle on a straight line is 180. Thank you very much. It's 180. So if I've gotten theta here, then it means that what is left here is 180 minus theta. So it means that the angle between the two lines, I will get one of the angle to be theta and the other one to be 180 minus theta. Okay. Now, if I call this angle here beta, and then the angle here lambda, then I have this one to be theta. Then I can write so many, I can use so many properties here. It says that observe that there are two distinct angles between L1 and L2. These angles are theta and 180 minus theta. Okay. Also from the above, my lambda, so I come here, I can look at lambda. So if I call this one lambda, I call this one beta, I call this one alpha. So these are just Greek alphabets that I'm using. So I call this one lambda, I call this one beta, I call this one alpha. I know that angle on this straight line, that between lambda plus alpha should give me what?
180 minus
180.
minus
It's
theta.
180. Oh no. I mean
180 minus theta.
No, I mean, sorry, alpha plus lambda. Alpha plus lambda is supposed to be 180. Is that not it?
Yeah, it should be
Yes,
180.
madam.
Yes.
So this means that my lambda will be equal to what? 180
180
minus
minus alpha.
alpha.
Minus alpha. Yeah.
So that is one observation. And then, so in that case, it means that the angle, total angle, is it, how do you call it? When I add beta plus theta plus lambda, I'm
Interior
supposed to
angle
get
per triangle.
180. So that one I'm supposed to get 180. And then I know that my lambda is 180 minus alpha. So this means that the interior angle will be beta plus theta plus 180 minus alpha. Or is the same as beta plus theta plus lambda is equal to 180. So when I come here, I'm going to get my lambda. So this lambda here, my lambda is equal to 180 minus alpha. And then as you just said, the total interior angle is also 180. So when I add everything here, I'm going to get 180. And I can make lambda the subject. Let me take my pen, write something. This is what I mean. When I take this on this straight line, I'm going to get my lambda to be equal to 180 minus alpha. I hope you get it.
Yeah.
Then when I take this total angle, I know that my beta plus theta plus lambda should be equal to 180. Then I can make lambda the subject. So my lambda will be equal to 180 minus beta minus theta. So here I have lambda is equal to 180 minus alpha, that is my lambda. And I also have lambda is equal to 180 minus beta minus theta. So if I call this equation 1, and then I call this equation 2, I can equate the two equations. Is it true? Because this lambda is
Yes.
equal to 180 minus alpha, and this same lambda is equal to 180 minus beta minus theta. Let me train it. Then we can continue. Please let me train it. Then okay. So I have lambda is equal to 180 minus alpha, and then lambda is equal to 180 minus beta minus theta. So when I equate the two, it means that I have 180 minus alpha is equal to 180 minus beta minus theta. I hope you understand this.
Yes, madam.
So I can make theta the subject. Okay. So this means that my theta, so my 180 can go with 180. Then I make theta the subject. My theta will be equal to alpha minus beta. Then I can take tan on both sides so that I'm going to get tan theta is equal to tan alpha minus beta. Are you with me?
Yes, madam.
But we know from double angle, compound angles, Frig, the expression for tan A minus tan B. My tan A minus tan, my tan A, turn into brackets A minus B is tan A minus tan B divided by 1 plus tan A tan B. So here I have tan alpha minus beta. So tan alpha minus beta is equal to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Do you remember that one?
Yes, madam.
Okay. So if you have forgotten, you have to go and revise. Okay, so let's continue. And I know that my alpha is the gradient for L1. Can you see it on the diagram? The gradient for L1 is alpha. Can you see it?
Yes, madam.
Okay. So that is tan alpha is the gradient for L1. So that means that my tan alpha will be M1. And my tan beta is the gradient for L2. So that will be M2. So this means that my tan theta will be equal to M1 minus M2 divided by 1 plus M1 times M2. That is the tan theta, the first angle between L1 and L2. But remember I told you that the angles are two. We have theta and then 180 minus theta. So we just proved that theta is equal to M1 minus M2 divided by 1 plus M1. So we want to find the other angle. The other angle will be tan 180 minus theta. So tan 180 minus theta is equal to tan 180 minus tan theta divided by 1 plus tan 180 tan theta. And what is tan 180?
0.
Tan 180 is 0. So it means that the top one will be minus tan theta divided by 1 plus. As you said, tan 180 is 0. So the other part, tan 180 tan theta will give me 0. So it means that tan 180 minus theta will be equal to negative tan theta. And we just got tan theta to be M1 minus M2 divided by 1 plus M1, M2. So it means that the angle, which is tan 180 minus theta, will be negative into brackets M1 minus M2 divided by 1 plus M1 times M2. So these are the two angles between the two lines M1 and then the two lines L1 and L2. But always remember that the gradient for L1 is greater than the gradient for L2. So anytime in the question, when you are given, you should look for the biggest gradient, and that will be for L1, and then the smallest will be for L2. So we have a question here. It says that find the acute angle between the line y is equal to 2s plus 1 and y is equal to 3s plus 2. Is there a hand up?
Yes,
Hi.
please.
Okay, Eric.
Please, madam, you go to the diagram. I want to ask something.
Please, I'm there.
You see that you establish a relation for lambda, then you equated them. What if I just take a beta plus
Please, I'm listening.
beta plus tan will give the exterior angle of alpha.
Theta plus tan.
Yes,
I don't
that's
understand.
the property of exterior angles. Beta
Theta.
plus this thing.
The two opposite.
It's beta plus lambda plus theta is equal to 180.
No, we mean
I mean, if we take beta plus tan, theta will give us the exterior angle of this thing, alpha, and you make look at the
And so
same thing.
anything that you know, any property that you know, you can apply it here. So that's one way of finding the angles. You can apply any property.
Okay, thank you.
You're welcome. Okay, so we have a question. It says that you should find the acute angle. I hope you know what an acute angle is.
Yes, madam.
Less than 90.
Okay, so remember that in this graph, we are getting two angles between the two lines. We have theta and 180 minus theta. So the acute angle we are looking for is the theta, not the 180 minus theta. So please put that in mind. Okay. So it says that find the acute angle between the line y is equal to 2s plus 1 and y is equal to 3s plus 2. So what is my M1 and what is my M2?
Madam, our M1,
The
is
coefficient of
3 and our M2 is 2.
Okay. So my M1 is 3 and my M2 is 2. So find the angle for me. So we know that it is tan theta is equal to M1 minus M2 divided by 1 plus M1 times M2. So this means I'm going to get 3 minus 2 divided by 1 plus 3 times 2, which is 1 divided by 7. Then I find the tan, that is tan theta is equal to 1 over 7, and then theta is equal to tan inverse of 1 over 7. And what will you get? You can use a calculator to get the answer for me.
8.13 degrees.
Okay. Is that all?
8.1301025354.
Okay. So this is the acute angle that we are looking for, 8.13 degrees. That's the acute angle. This example, I will give it to you to try. And when we meet next time, we'll discuss it. Is there a hand up?
Yes, please, madam.
Okay.
Madam, please, can you go back to your last slide where you got M1 to be 2?
Is it this?
Yes, please. From the question,
M1 is 3, M2 is 2.
but in the question, y is equal to 2s plus 1 supposed to be our M1.
Why? Why do you think that it should be M1?
So the question says we should find an acute angle between the lines y is equal to 2x plus 1. So that's the first equation. And the second equation is y is equal to 3x plus 2. So which one should you consider to be the M1 and the
So
M2?
who told us that M1 is 3?
Madam, please let me answer him.
Hello,
M2 is 2. Who said it?
Madam, please.
Madam, please let me answer him.
Okay.
Please continue to look about.
Okay, so answer him.
When you look at
Somebody wants to answer
our slides, in the slides,
him. The person to answer.
it is stated that the one with the highest gradient is the M1, and the one with the least gradient is the M2.
Okay.
So looking at the two equations,
Thank you very much.
the second one has the
Thank you
highest
very
gradient.
much.
Hello, madam.
Okay, so it's here. It says that consider the line L1 and L2 with gradient M1 and M2 respectively. Suppose that M1 is greater than M2 and both of them are greater than 0. So it doesn't matter which one comes first. Usu.
Okay, madam.
Hello, madam.
Hello.
Madam, please, considering the value of tan inverse of 0.1429, and you were getting 8.1325. I want to ask whether you will be told specifically to round it to a certain number of places, or we should write it fully as has been written there.
Oh, this one is not important. You can just write 8.1. I think 2 decimal places is appropriate. So maybe 8.1. But mostly it will be appropriate. You can even write it 8.133. It's fine.
If you write up to 4 decimals, but 2, it's okay. 2 decimal places or 3, it's fine. The decimal places, for now, dear, we will not talk about it now. But I think 2 or 3 is okay for now. Okay, so as I said, I'm not solving this now. I'm giving it to you. You take your time. So I even have to give the question without the slides, so that when you are done, I will send the slides to you. Because I want you to go through this. And in this, you have to apply so many things that we have done today to solve this. So please, I will send the question to you without the solution, and you solve it for me. Are you okay?
Yes, madam.
Yes,
Do
Doc.
you understand?
Yeah.
When do we go for break?
Since on this we don't have break,
When is
madam.
our break?
We have
On the
break.
timetable, no break.
On the timetable,
There
Sunday
is.
second lesson, we
What
don't have break.
time?
Sundays we don't have break.
Yes, sir.
Yeah, we don't have break for Sunday because we close 2 o'clock.
It's 11:30 to 3:30.
We're going check.
I
It's
hear.
2 o'clock.
It's 3. It's 3:30. Okay, so I'm looking for the link. I want to open it on my laptop.
Now let's break. Let's break.
Is the link on your platform? On the platform?
Yes,
The
madam.
WhatsApp
Yes,
platform.
madam.
yes.
Okay. Then let me copy it. And send it to my email.
Madam, please. Some of us are from IT, and we are not on the platform.
Okay.
So if you put a question there, I don't think we will be able to get a question.
So what do we do? Where do I put the question?
Madam, you put it on the platform. Maybe if they need it, they will get it from the course rep.
And we don't even know the course rep, but our course rep is here, so I think course rep will
If you need a fix, yesterday that's the same thing you people you add
Guys,
you add
please,
as a
guys, we have a course rep here. The online centers, we have a course rep here. That's Justina and Easter.
Please,
So
I
I don't really
suggest
know
you
the reason
break
why
it
you
for
people
like
are saying you don't know
10
the course
minutes so
rep.
that you use
Please.
that time to connect your laptop and share your
Madam.
screen with the person.
Madam,
Hello. Yeah.
madam, please, the 4 hours straight is something. So if you can, we agree that we are break at a point, so that we can stretch for.
Today is not 4 hours. So.
Madam, from 11:30 to 3:30 is 4 hours.
It's 3:30. It's 4 hours.
Madam, it's 2 o'clock.
It's true.
Go and check the timetable. It's 2 o'clock.
No, it's 3:30.
Madam, I just like the timetable. Sunday second lesson is 11:30 to 2.
Sunday, 2 o'clock. Share it, let's see. Share it, let's see.
Maybe that's
Okay, so I
ICT
think
people. Mass our
I'm
own
now on my
3:30.
I'm now on my laptop, so we
Yes.
can continue. Okay.
For mathematics,
On the
is
laptop.
3:30.
Oh, okay. So we are continuing.
Hello, dog.
Hello.
Dog.
Yes. Please, can you hear me?
For the mass department, we'll be closing exactly 3:30.
3:30.
Yes.
No, it's 2 o'clock.
Oh.
The
It's 2
timetable I
o'clock.
have is
I just shared
3:30.
I just shared the timetable in the group. Let's check out and find. I just share the timetable.
Yes, yeah, I'm from the IT, but it's 3:30. It's 3:30.
My
The one that I
timetable
have.
is 3:30.
Yes,
It's
it's 3:30.
3:30.
Maybe his own. I don't know where he got it from.
It's true. On the timetable, Sundays is up to 2 o'clock, but I don't know why they have extended it. It's up to 2 o'clock. That's the timetable they first brought initially.
Maybe it has been changed.
Maybe they have changed it, but initially that's what we were having.
So we are not using the initial one.
Hello, madam. The only
Okay,
center
so we
added
are.
to our center is the UCC. The only center added to our online center. This is strictly online center. The only center added to the online center is the UCC. So if the so-called IT people, they should go to their centers and then go according to their timetable. We are having our timetable. They can dictate for us.
It's
Hey,
true.
boss,
They are
Sorry.
making
please.
Oh, but
good.
I
They
think
are
Let's
all
continue.
they are all online. Oh. They are
Why?
all
This
online.
guy was
They
wrong
are
with
all
you. I
online.
can't
So
see anything about you from the IT.
boss.
Hey,
Talk well. Talk well.
Please, let's
what is the meaning
continue.
of so-called IT?
Let's continue. Mute yourself and let's continue. So we are using my timetable,
What is the meaning of the
and my
so-called IT?
timetable says that I'm supposed to finish at 3:30.
Go by your
Yes,
timetable.
madam. Yes.
And who said about
So let's continue. Okay, so now we want to look at division. We want to look at division of a line segment in a given ratio. We just looked at division of a line, or find the midpoint of a line. Now I want to look at division of a line in a given ratio. So this one, we know equal division, but here we want to look at in a given ratio. So we'll discuss about the external and internal division of line segments. To find the coordinates of point dividing the line segment joining two given points in a given ratio. So I want to look at
Hello, madam.
Madam, please, you have muted yourself.
Please, we can't hear anything. Hello, madam.
Is that so? I was teaching you. Sorry. I'm sorry.
Okay, we are not hearing you. Okay.
Okay. So as I was saying, I am saying that now I want to look at how to divide a line joining 2 points A and B, how to look at the internal division of this line in a given ratio, and the ratio is n:m. So this one is not equal division, but there is a ratio n:m. So if I have my A with coordinates x1, y1, and B with coordinates s2, y2, and I want to find a point R, and this R is dividing this line into a given ratio n:m. So let's find the coordinates of that point too. Okay. So I will draw. I have my y and then s axis. Then I have this line E with x1, y1,
Madam, please, your voice, we can hear your voice.
Hello, madam. We can't hear you.
I didn't mute it. What is happening? Who muted me?
Sometimes network.
No, you can hear me now. When
Yeah.
I came here, I was muted. I don't know why. You hear me now?
Yes, madam, we can hear you.
Okay, madam. Go again. Let's see.
Okay. So I want to look at the final division of the line A and B and the ratio N to M.
Guys, mute yourself.
Am I muted
Jacob
again?
too. No, man.
Okay. So in this case, it means that the point here is here. I have X. So if I call this points, let me see what I have here. So I call this point C. And the coordinate of my C will be X, comma, Y1. So here will be X, comma, Y1. Then I draw this one here. I call this one D. And this one will be S2, comma. What is happening? I went off again. Hello?
Hello?
Yeah, we can hear you.
Network. It should be the network.
It's not the network. Oh, it's not the network.
No, the time is just tired. Time is tired.
Okay, so let's continue. Okay, so the distance from here will be X minus X1, and the distance.
Hey, again.
Again.
It is telling us to go.
Isaac, your hand is up.
Time want to go to break.
Time is lying.
Madam, please, if you can hang up and come back again.
Exactly. Okay, then let me hang up and come back again.
Let's wait for 5 minutes, then you check it.
Okay, let me. Okay, let's go off for 5 minutes. So we'll come back at 1:20.
Okay, yay.
Oh, what time are we supposed to go for break? Let me check. What time are we supposed to go for break?
We don't even know.
Madam, this one there's no break.
No break.
It's a marathon lesson.
So we can't be on live for 4 hours. There should be a break.
I'm even dozing off.
So we'll come together with Madam to get a break for maybe some few distance. So Madam can tell us to go for maybe 30 minutes or 15 minutes.
30 minutes is too much.
I'm just suggesting. I said 15 or 30.
I agree with the 30 minutes.
30 minutes is too much.
Then 20 minutes is okay.
I'll check the timetable and see. But the timetable is here.
Madam, it's 11. We are stopping at 3:30, Madam. So that at least
so you can break for some.
At least Madam would have prayed after maybe 1:30. We just come back.
1:30 is okay.
I wish I can finish with this one. How many slides left? 2 slides. So let's finish with this one and then maybe break for.
Yes, Madam, let's continue.
So let's continue with this one. Break for some time. So I will not draw
Yes, Madam, sure.
I am off again.
Okay, so
let me just try and minimize this so that it will be somewhere. I will minimize this. Okay. But can you see the screen?
Yes, madam. Yes.
Yes, madam. Yes, madam.
Okay. But can you see the drawing?
It's too light.
Madam, it is faint.
Yes, madam.
Is it small or
Zoom
faint?
it, zoom it for us. Zoom it a little bit.
Madam, faint, very faint.
Hey, then. Is it okay?
Yeah, madam, it's okay now.
Okay. I want it to be so that when the thing goes up, I'll say it. Okay, so as I said, the distance
Right,
from
the noise from your guy is different.
the distance from A to C is x minus x1. And then the distance from R to D is x2 minus x. The distance from C to R is y minus y1. And then from D to B is y2 minus y. Just like what we did for the midpoints. So we can see that but it's given in a certain ratio. So here my AC divided by my RD will be N divided by M. This one is a given ratio. So I have AC, the distance AC divided by the distance RD, and this is equal to N over M. So that's what I have here. So I have AC over RD is equal to N over M. And then I know that my AC, my AC. Martin. Yeah, AC is x minus x1, and then RD is s2 minus x divided by N over M. Okay. So we cross multiply and we're going to get M into brackets x minus x1 is equal to N into brackets x2 minus x. So we want to make S the subject. So we open this one, I'm going to get mx minus mx1 is equal to nx2 minus nx, making S the subject. So I'll bring this one to the other side. I'm going to get mx plus nx is equal to nx2 plus
Madam, it has gone back again. Madam, check the mic.
Yeah, I've done it. So my mx2 plus mx1 divided by n plus n, that is my x coordinates. Then I can find my y coordinates. My y coordinates will also be, that would be ACR. So the distance from C to R divided by the distance from D to B will be in the ratio M divided by N. So that one to be, so that one will be R, distance from R to C divided by B to D, and this is equal to N over M. So this y minus y1 divided by y2 minus y is equal to N over M. So you just cross multiply, then you make y the subject. So when you make y the subject, you're going to get your y to be N times y2 plus M times y1 divided by M plus N. That is my y. So this means that my R will have the coordinates, the x coordinates, and then the y coordinate. That is for internal division of a line in a ratio n is to m. That's all we'll get. Then the next we want to look at external division. External division. So when you talk about external division, it means that there is an extension. Extension. So we have the point still AB, then we'll have extension. So the extension can be on the B, so we extend it from the B, or we extend it from the A. So this one we can see that we have A and B here. And when we extend it from the A, we're going to get the R to be here. So we're going to get negative N, and then the whole thing here will be our positive N. So the same approach as we did. So we have to find the distance from A to D, A to R. So A to R will be here. Then I will find it from B to R. So it is here. So I can find my X. So this one will be from R to A. I'm going to get X1 minus X. And then from my R to B, that is for the D one, I'm going to get S2 minus X. And then the Y will be Y1 minus Y, then Y2 minus Y. So using the same method that we used, you're going to get our X to be M times X1 minus N into X2 divided by M minus 1. And then the Y coordinates, when we write it and we play around, it's going to get our Y to be M times Y1 minus N times Y2 divided by M minus N. So this means that my coordinates will be M x1 minus N x2 divided by M minus N, then M y1 minus N y2 divided by N minus 1. Okay. So that's when the extension is on from where the X is, A is. Now, if the extension is on top of A, on top of B, then it means that my M will be negative. When it is down under Y, the negative will be negative, it will be negative N. But when it is above B, it will be negative M. Okay, so it says that similarly, if R divides the line AB externally such that AR is to RB is equal to M is to negative M. So in this case, the negative will not be attached to N, but it will be attached to the M. So I'm going to get minus MX1 plus NX2 divided by negative M plus N. Then I have minus MY1 plus NY2 divided by minus M plus N. That is it. So there is a question. It says that find the points dividing the joining of A and B. So A internally in the ratio 1:2. So internal division, we know that the internal division is given as MX1 plus NX2 divided by M plus N. And then MY1 plus NY2 divided by M plus N. This is it. The ratio is 1:2. So I know that my N is 1, my M is 2. Please, can you see it? That always the first one N, and then the second one is your N. So that's my N, that's my N. So I'll do the substitution, and I'm going to get 5 on muted again. So when I saw, I'm going to get 5 on 3, 5 on 3. Then the next one is internal division. Here they've written -1 is to 2. Please, when you are solving, this means that the negative is for the n. So when you are solving, you quote this formula. When you are substituting, you will not substitute -1. You have to substitute 1. We are bringing the negative here to show that it is to the n. So you will first bring the negative here. You will not, in the substitution, you will not bring -1. You will bring 1 for n. Are you with me?
Yes, madam.
No, madam. Please, madam, come again.
What I'm saying is, they are saying it is internal division in the ratio -1, 2. So the negative, we brought the -1 here to show that the negative is for the n. So it means that we are using the first formula where the n is negative. So in solving, you will not bring negative and then bring -1 again. You will just write 1. You will not write -1. So assuming I have -2 here, so it means that I have to write the negative and bring 2. So let's even see how we solved it. So in solving, I'm saying that now the formula is mx1 minus ns2 divided by m minus n. So when I am quoting, my m is 2. I have the negative here. In the question, they wrote -1, but I wrote 1 because it is already negative here.
Huh?
Get me? Do you get me? Hello? Okay. Because it's already negative,
madam,
the n, I will just write 1. I'm not repeating -1. So please, you write 1, then you have 2 minus 1. Then you just substitute, you simplify, and you're going to get -1, 3. That is it. So we have come to the end of lesson 1.
Madam, please, I have a question.
Okay.
So it means that externally, the ratio that they will give you, where they will indicate the negative sign, will tell you the formula you must use. Okay. So
if I bring the negative
signs at the end, like 1 is to -2, then like we'll use the second formula.
Second one. Yes.
Okay.
But
Thank
in the
you.
substitution, you don't bring the negative again. You
Yes,
just bring
yes.
negative, then you write the 2.
Okay. Thank you,
very
madam.
much. You're welcome. So we have some
Hello,
questions
madam.
here. You can try your hands on. So this is the end of the first lesson. We'll come back and continue. Mubarak, your hand is up.
Madam, please, the last slide before this one. I mean the assessment, self-assessment.
It's here.
Yeah, thank you, madam.
I want to take a picture of it. Okay, thank you very much. So
Please, madam, can you share the slides for us?
Can I do what?
The slides, can you please share it with us?
I want to share it, but because I want to give you this question. Where's the question? There's a question that I want you to try your hands on. And I said that I don't want you to copy. So I want you to finish solving before I share the slides with you. So that is the question. You can take a picture of it. Even this one is not part of the solution. So please don't take a picture of the solution. Take a picture of only the question. Don't add the diagram. It's not part of the question. It's part of the solution. Are you done with the question? Taking a picture of the question.
Yes, madam.
Okay. So let's break for about 15 minutes and come back. So this means that we'll come back around 1:47. Okay, so thank you very much.
Thank you, madam. Mr. Adam, you can rest now.
Course rep. Please, who is the course rep?
We are here.
Muniru, I'm resting.
We are here.
Okay, boss.
Course rep. The advanced algebra and then calculus, the material didn't share for us. I have not yet taken it.
Platform. Muniru.
No, you shared it and then you created a group.
You
So
said?
if
You created a new group. You didn't add us. Hello, Mr. Muniru. Okay. Where is he?
Yes, madam, I'm there. Any problem?
You didn't add us yesterday.
Okay, Issa, I hope you are taking notes.
Who is
Mr. Issa?
Yes.
Mr. Issa, please, I will suggest that I'm sure they also have a platform. As of their class rep, their class rep, and take his number, then you forward it to him, so you also put it on their group for them. Then they adding themselves to our platform, because sometimes we do group work, and the group work sometimes do affect some. I get
So why don't you create a group for those doing algebra
even presentation like this, he might not be there.
Yes, they will not be there to present, and it will go against some of us that will be under the same group. So you take their class rep number, then you forward it to their class rep. The class rep also for.
Course rep. Why don't you create a different group for analytical geometry and calculus?
The way the grouping, if you want to try creating, it will be too bulky in our distance. You understand?
Because
so
sending some information might be important, but you will feel it will not be important, so you will not send it. Do you get it? So I feel you should create a common group for us, so that we all get access to information.
For all the IT,
to him. He knows that this is coming from this. So when any information that is coming from him should be given to you. He shouldn't keep any information that is coming from our course.
We forget
every information that coming from him. You should send it to your platform.
Take Madam Bennett's number, forward it to Madam Bennett, so that she'll put it on their platform. Thank
very
you.
well.
Exactly.
Can you
okay.
send it to me? Then I'll put it on our platform.
We have never kept any information to ourselves. Any information that comes, we display it. I always allow Madam Justina to do the sharing.
So yesterday, did
always send the information.
Slide for algebra.
Madam has not yet sent the information yet.
Even sometimes when they give us the information, we don't even read it, or we forward it straight.
Yes.
We never
So
give any
Madam has
information.
not yet given us out the information. So you exercise patient as to when Madam, after this, I'll find out from her, then she'll forward it, then we'll give it out to you.
Even with this course, we have to create another group.
Yesterday, you made us aware that you add us to a group. We were not informed that you forward anything else. And that's what my sister is actually asking.
No, Madam said she will forward out the information yesterday, so that we'll start preparing ahead of our next meeting with her. And because she was not well, I didn't put pressure on her for that information. So it's after today that I'll pick the information from her, then we'll forward it to the platform.
Okay, because yesterday
she gave me the slides and I kept it on the platform. She gave me the slides.
Which platform?
Very well.
Yeah,
the platform
is there.
Very well.
But you forward to Madam Bennett so that Madam Bennett can also forward to.
So Madam Bennett should give me the number right now. So I'll just forward them. Madam Bennett, if you can hear me, give out the number. Hello, Madam Bennett. Okay, very well. Noted. I've seen it.
Coach Rep, this time we are not getting the slides.
Which slides?
That is the problem.
Which slides?
We are not getting them.
Which one? Which one have you not gotten? I want to know, please.
The one that we did in the morning. I didn't see that one.
It's in the platform.
Please, which platform? Which one?
Is it the one you created new or which one again?
Yes, the one we created, the new one. We kept it there.
Mr.
You shared it before some of us joined, so we will not see.
You hardly get everybody on board.
So in that case, once you just joined, you could have just say hi. Then I will not know whether you have received it or not. I don't know whether you understand. So once you just try to buy it. So what we'll do is right now I'll just forward the information to the platform right now. Once we fall or join, I'll re-forward them back. Then you pick it.
We are all in one particular group. You can send it to that particular group other than the one that you've created. Okay.
Please, the truth of the matter is that sometimes one can be at let's say UCC center, but will not be the person is face to face. And once he's there, sometimes because of this issue, he wants to join the online and he will have certain things to we those who are online. So sometimes our number are more than the exact number of those in the online distance. So sometimes when it comes to presentation like this, we find ourselves very difficult in getting ourselves. At the end of the day, you see the person going to a different place. So this time around, we just want to.
About you sending the file. So this one, why should?
So that's what I'm saying. This time around want to make sure that all those who are this material goes strictly to only those online. Please, you can. If my message is not going well, you pardon me. But I want us to know that this time around, last semester or first block, it happens that most of us were not even on the online. Just that we tried joining. So anytime it comes to presentation, we find ourselves at least in a group. You see only 3 or 4 people presenting. Meanwhile, the number is more than 5, 6. So this time I want to make sure that we at least come together to see how best we can. So, but Ms. Odro, whatever it is, you just hi me. I'll give my number to you. Then I'll forward the listen to you. Then those respected persons that you can also forward them out.
Okay, I hear. Just that my only concern has to do with definitely we are all in one umbrella. We are all under one umbrella.
Yes, yes.
So if you forward to that particular group, those concerned, those who relate to that particular course, so they can download and then. But
very well. Very well. Well noted. Well noted. Thank you very much. We'll do exactly that.
Thank you.
I'm not an umbrella.
Mr. Karim. Mr. Karim. Mr. Karim. Sir Karim. Sir Isa. Hello.
He's off.
Oh. Indeed, what he was saying was right. But then sometimes too, people or colleagues from other centers may like to join online, not necessarily because maybe they want to skip the face-to-face. But sometimes you go to the face-to-face and then the kind of tutorials you get or the kind of lectures you get there, you see that joining the online will be preferable, depending on the lectures at various centers and then the online platform. So it's not necessarily somebody wanting to escape the face-to-face or by distance, the person want to join online. So if once we are all on the same umbrella, if materials or information are put on one thing so that whoever is on that group can access it, that would be better, in my opinion, though.
Well noted. We will take it into consideration.
Please, he's not saying that he wouldn't share the slides. So we are much concerned about the group work. That's what the first block we faced so many challenges. He kept us in groups. At the end, just 2 or 3 people that came out and presented, and it affected them. So that's why I was saying this time that he has to take caution of that. So that if you are in a
Sharing of
particular
this
center,
message should
if
not
you are in a particular center,
be based
you will
on
know
doubt.
those people that are in that particular center. So you send it to one person to also share it in that group. If not, if you need to add all of you to that particular group, it will end up affecting us this second block again. Thank you.
All right, so Madam Maria, this time around, I think since they also have their course reps, he can compile the names in case we have any presentation. He can compile the names and give it to Issa to add them to that. So I think that one will be handled this time around.
That's okay for some of us. Thank you.
Good afternoon. Some of us we just joined. What's up? What is going on?
Charlie, rest, you are late.
We
have done a lot, seriously. But don't worry, when they share the slide, you can read through.
Handsome on. So
Yeah, good
can
afternoon.
somebody?
How are you doing? Please, is the lesson over?
Isaac, are you there? Today we didn't hear your voice.
Well, we're supposed to welcome.
Oh, you are Miss Badley. Welcome.
Thank you.
Welcome.
How are you doing?
We are fine, Mr. Wilson.
What is going on?
You see, today we joined the class because you are not present. Oh, why? What happened?
We're supposed to know your channel.
Is the lesson over?
No, we are on break.
Very funny. Nadia.
We're supposed to see
We'll come back.
I think one is 147.
It has left you with a minute. A minute more.
Okay. I hope you enjoyed the lesson a lot. Mr. Enim, if you are on the platform, produce your image. I just want to see your face.
Hey, I'm crying.
Hey, Asapa, yeah, Mr. Buntu.
Please, it's unrecorded, so let's keep that one for now.
Hey, hey, for you, I didn't know. Hey, ah,
Hello. Hello.
Hi. Hey,
Hi.
madam, was that you on the GP?
Thank you, Maria. It's a Mario, it's a Maria, it's a Maria. Thank you.
It's Maria.
Maria, yeah, thank you. Please, we want to start now. So far, we know how to find the distance of a straight line or if a line segment. You know the distance formula. You know how to find gradients, equation of a line, angle between two lines, relationship between lines, and others. So now we want to continue. And right now, what we're going to do, by the end of this section, you should be able to identify equation of a circle. You should be able to find the center and radius of a given circle, find the equation of a circle given the coordinates of the endpoint of the diameter, find the equation of a circle passing through 3 given points, find the equation of a tangent and a normal at a given point on a circle, and also find the coordinates of the points of intersection of a line and a circle. And I know that some of you can do all these things right now, all these things here. So the outline of the presentation will look at equation of a circle in a standard form and general form and properties of a circle, determination of center and radius of a given equation of a circle on a diameter, a given diameter, equation of a circle given 3 points on the circumference, find the equation of a tangent and a normal to a circle at a given point on the circumference of the circle and an intersection of the line in the circle. Okay. So want to start equation of a circle and a standard and a general form and then properties of a circle. Okay, so we all know what a circle is. So we always talk about circle. So draw a circle, draw it in a circular form and others. So when we talk about a circle, we say that a circle is a point, is a set of all points in a plane which moves such that it is at a constant distance from a fixed point. So you stand here, and wherever you move on this thing that we've drawn here, we call this a circle. When you stand at C, wherever you move to touch the circle, it will be the same distance. So from here to this point on the circle is the same as from C to this point of a circle. So we call this point here the center of the circle. And then from the center to any point, we call that distance the radius. So from C to the point P, we call that distance the radius of the circle. And I call this one the center. It says that the constant distance is the radius and the first point is the center. So this first point, the middle of the circle, we call it the center of the circle. So we want to look at standard equation for a circle using the distance formula. So we know the distance formula already between 2 points. So here I'm looking at the point C and the point P. So we saw that if I have a point C and a point P, and then I want to find the distance, it's going to be x square root of x minus a squared plus y minus b squared. That is it, the distance. So it says that the equation of a circle can be written given the radius r units as. So the distance from C to P is square root of x minus a squared plus y minus b squared. And I just told you that from C to P, we call it the radius. So from here to here is the radius.
So it's the square root. If I want to take the square root out, I will square both sides. And I'm going to get r squared is equal to x minus a all squared plus y minus b squared. So it says that squaring both sides of the equation, I'm going to get r squared is equal to x minus a squared plus y minus b squared. And when I write it in this form, we call this one the standard form of equation of a circle. So when we are asked to write it, equation of the circle in the standard form, is giving us r squared is equal to x minus a squared plus y minus b squared. Now, if the origin is the center, so if my center is here at the origin, it means that my coordinate C will be 0, 0. So my A and B will be 0, 0. So it says that if the center is the origin, then the equation of the circle will be what? X minus 0. So I'm going to get x squared plus y squared is equal to r squared. So it says that if the origin is the center, what's the main card here? Rachel,
We can hear you, madam.
Rachel, your hand is up. Okay.
Yes, please. The writings are too small. We can't see. If you can zoom it a bit for us.
You can also zoom it from your side.
Is it okay, Richard?
Okay.
Madam, when you zoom it become a bit broader on our phones. So if you let it be okay. If you want to, you can individually zoom it for yourself. That one is okay. Like looking at how you have done it, we cannot see all of it.
Is that so? Okay. So here if the center is 0, 0, then the equation in the standard form will be x squared plus y squared is equal to r squared. So there's a question here. It says that find the standard equation for the circle with center 0, 0 and then radius square root of 13. So we just saw that to write equation in a standard equation of a circle in a standard form, it is x minus a squared plus y is b squared is equal to r squared. If it's like this, we call it the standard form. Then in the question, we are told that, okay, so this one, the center, this means that the center is AB. And then my radius is R. So if the center is AB and the radius is R, the equation of the center equation is given as this. But in the question, we are told that the center is the origin. So the center has coordinate 0, 0. And my radius is square root of 13. So I want to find the equation of the circle, and it's going to be x minus 0 squared plus y minus 0 squared is equal to 13 squared. So this will give me x squared plus y squared is equal to 13. Are you with me?
Yes, dog.
Yes, madam.
So it says that now center is 0, 0, radius is square root of 13. So we substitute a equal to 0, b equal to 0, and r equal to square root of 13 into the standard equation of a circle. So this gives us 13 squared is equal to square root of 13 squared is equal to x minus 0 squared plus y minus 0 squared, which is 13 is equal to y squared. Therefore, the standard equation of the circle with center 0, 0 and radius square root of 13 is x squared plus y squared is equal to 13.
Then we have another example. We want to find the equation, standard equation of a circle with center 0, 0, which contains the point P 4 with coordinate 4, 0, 4, negative 1. Okay, so let's see if we can solve this one too. So this one, in this question, we have the center. Our center is 0, 0. Then there is a point P with coordinate 4, negative 1. Is it 4, negative 1?
Yes,
so how do we go about this one? Here we are not given the radius. So how do we go about this? What is it?
Here you substitute the points in the given equation, which is a standard formula or standard form.
Okay. And what will you get? Okay, so we know that the standard form is x minus squared plus y minus b squared is equal to r squared. But we know that for this one, it means that my center is AB. And then my radius is my r. But in this question, we're given the center to be 0, 0. And then another point P to be 4, negative 1. So how do you go about it? So we can sketch
madam,
it.
I think. Please, madam, I think
let me just try and sketch it. We'll put the positive 4, negative 1. So positive 4, maybe 4 here. Let me, how do we sketch it? There's a point. Okay, I didn't sketch it well. The center is 0, 0, sorry. So the center is 0, 0. Center is 0, 0. And then they are saying that we have the point 4, negative 1. So this P is 4, negative 1. And the center is 0, 0. So how do you go about it?
Please, madam.
Hello, madam.
From the first one, equation of a line, we can find the length of a line. We can find the radius with that 2 points, which is the 0, 0 and 1 point on the circumference. So we can find the length of it to find the radius.
Okay, so he's saying that the point CP is our radius. So let's try and find that point. So please find the distance for me. So CP, D of CP, which is the same as R, will give me square root of 4 minus 0 squared plus minus 1 squared, which is equal to square root of 4 squared plus 1 squared. Okay, which is root 17. And so he's saying it's 72 units. So the equation will be x minus 0 squared plus y minus 0 squared is equal to square root of 17 squared. So the equation will be x squared plus y squared is equal to 17. Did you all get it?
Yes, please.
Yeah, it's okay.
It's okay. Eh?
Yes.
Yeah. Madam, we can also use the standard equation that has been given.
Okay.
Which has to do with x minus a square plus y minus b square equals to the r square. You know, we know the coordinates has been given. We know a is equal to 0, b is also equal to 0, which are the origin, the center points. Then we know our x to be 4 and our y to be -1.
Okay.
So when we substitute those into the formula, we'll have 4 minus 0 squared plus -1 minus 0 squared equals to r squared.
Okay.
So our r squared will be equals to -4 squared plus -1 squared. Well, we'll get r squared to be equals to 17. So the equation of the circle will give us 17 equals to x minus 0 all squared plus y minus 0 all squared. And at the end of the day, we'll get 17
the same solution.
The same solution.
Okay, thank you very much. Edward, I saw your hand up. Okay, so I think that for mathematics, the most important thing is to get the concepts right. So any approach that you use, you're going to arrive at the same solution. Thank you very much. So we're going to get x squared plus y squared is equal to 70. Okay, I want to continue. So that is the standard form. The next we want to look at the general form of equation of a circle. So let us consider the standard form of equation with center circle with center AB and radius R. Then the equation of the circle is given as, okay, so expanding and simplify. So it's given as x minus a squared plus y minus b squared is equal to r squared. So when we expand this, you're going to get r squared is equal to s squared minus 2as plus a squared plus y squared minus 2by plus b squared, which is the same as s squared plus y squared minus 2a s minus 2by plus a squared plus b squared minus r equal to 0. Now, if I let my a be equal to negative g and b equal to minus f, and my c be equal to a squared plus b squared minus r squared. So in place of a and b, I can write it as c is equal to minus j squared plus minus f squared minus r squared, like that. Then if I do that and then I rewrite this, I know that my a is minus j squared. So, and then my b is minus f squared. And the whole of this is my c. So the equation will be x squared plus y squared minus 2jx plus 2fy plus c equal to 0. And when we write the equation like this, we call this one the general form. Okay, general equation of a circle. So this is known as the general equation of a circle with center minus g minus f and radius square root of g squared plus f squared minus c. So we want to continue. So we want to look at some properties of a circle. Always note that the coefficients of x squared and y squared are the same. So when you have an equation and want to find out if it's equation of a circle, make sure that x squared and y squared have the same coefficients. So if you see something like this, okay, so let me just continue. That is one. Then the second one says that there is no property in x, there is no term in x times y. And the degree of expression in x and y is 2. So the degree for x and y are supposed to be 2. So we can have something like this. Okay. So I'm going to write some equations, and then with the properties that you know, you tell me if what I've written
Madam.
Yes.
Like Madam has muted herself.
Please, madam, are you talking?
No, please.
Okay.
Yes. Is there a hand up?
Yes, madam.
Okay, so please, why is your hand up? Okay, I can see Samuel and Bawa or Steve Luce, Stephanie. Please, where is your hand up, Sammy?
And I want to answer the question.
Okay, you want to answer. Okay, so please, is the first one equation of a circle?
No, madam.
Why?
Because the coefficients of the x square and y square are not the same.
Do you agree with him?
Yes, madam.
Yes, madam.
The second one is the equation of a circle.
Yes, madam.
Why?
Madam, because
of x and y.
the coefficients of the x square and the y square are the same.
Okay. And what again?
And there's no XY term.
And there's no xy term in it.
Okay. And what again?
The degree of S and Y is 2.
It's 2. Thank you very much. Then let's look at the third one.
Use it.
Madam, the third one is not an equation of a circle.
Okay, why?
Because there is xy term in it, even though the coefficients of the x square and y square are the same.
Okay. And what again? And the degree is also 2. Okay, what about the third one?
Madam, it is not.
Why?
Because if you check the degree of the y, it is cube.
Okay.
And that it is not an equation of a circle.
Thank you very much. Let's continue. There's a question. It says that find the general equation of a circle with center 2, -2, and radius 5. Should I allow you to do it?
Yes, madam.
Okay, so solve it for me and let's see what you get.
Madam, we just saw the solution. Oh.
You saw the solution. You didn't see all. You didn't see all, please. So solve it. What did you get? Are you done? Are you done?
No.
We are on.
Okay. Okay, so there's a hand up.
Okay, madam, can I try?
What is Sammy? Your hand is up.
Yeah, madam. Please, I had x squared plus
Okay,
y
so
squared.
tell me the procedure. How did you go about it?
Madam.
Mm-hmm.
Madam, in this particular question, the R is given as 5.
Mm-hmm.
So
let all of us listen. Oh. Please continue. Sammy, continue. Sammy, continue. Hello, Sammy, where are you?
Sammy is missing.
Bewa, please continue for Sammy.
We know the general equation or the formula to be x squared plus y squared plus 2jf, 2jx plus 2fy plus r equal to 0. So here we know our center to be 2 neg 2 and the radius to be 5. So we fix into the formula and the center with the general equation. The center is negative f, negative j, negative f. So when we substitute it inside, we get x squared plus y squared minus 2x plus 2y plus 5 equal to 0. Yes, that's
what she got. Any other alternative solution? Thank you very much, Bewa. But any other alternative solution? Kweku?
Hello, madam. I had x squared plus y squared minus 4x plus 4y plus 17 equals to 0.
How did you?
I use the general.
We have to find the general.
I use the general.
No, you use the general. You have to find the general equation. So you didn't use the general.
I use the formula r squared equals to x minus a all squared plus y minus b all squared. Substituting r was given. Now the other point which was given us 2 and then negative 2. I replace them with a and b and then do the expansion and had x squared plus y squared minus 4x plus 4y plus 17 equals to 0.
It's negative 7.
Okay, so somebody had 17, another person had negative 17. Any other alternate solution, or that's what you all got? Okay, so let's see what I have here. It says that from the general equation of a circle, the center is given by negative G, negative F. So comparing with the center here, my G is -2, my F is 2. So when I compare this to this is supposed to be negative, they're supposed to be positive. And then I know that in the general formula, I have to find C. My C is G squared plus F squared minus R squared. So it means that I'm going to get -2 squared plus 2 squared minus 5 squared. And this is 4 squared plus 4 squared minus 25, which is -17. Then I go back, I'm going to get, so now substituting J is equal to -2, F is equal to 2, C equal to -17 into the general equation of a circle. The equation of the circle will be x squared plus y squared plus 2. So remember, it's supposed to be plus 2f plus 2gx. My g is -2, so 2 times -2x plus 2fy, and my y f is 2, so 2 times 2y plus -17 equal to 0. So when you expand and simplify, I'm going to get x squared plus y squared minus 4x plus 4y minus 17 equal to 0. I hope you all got this.
Yes, please.
Then there's another question. We are asked to find the center and radius of this circle.
Hello, madam.
Hello.
Yeah, please. I used the first equation, the equation of a circle. R squared is equal to x minus a all squared plus y minus b squared, and I think I also have the same thing.
And so that's what we want to get. But I think that because we are treating that one, I wanted you to use the G and then F. Because
Okay.
because
I didn't get that concept here.
Madam, the question use the general formula. So
That's
when
what
they
we
are
are.
marking, that
No.
is how they're going to.
When we are marking is different. The marking, we just want you to write it so he can use that one to arrive at this. But this is the topic I'm treating now. So you have to play with the G and F. But in the exams, you can do this and you get the same thing.
I do understand, no, but the question is, in the exams, when they make it specific that use the general formula.
Find the general formula. Well, no, in the exam, when I ask you to find the general formula, he can still use the first one and get the same solution.
Okay.
Please find the center and the radius of this circle. What is the center of this circle? Can someone tell me the center? I have 4. The center is
0, 0, 0.
It's 0, 0.
And the radius?
The radius is
5.
The radius is
5.
5. The radius is 5.
Are you sure?
Yes,
5 over 5
5
over 2.
Those of you who said
It is
5,
5
give
over
yourself, give yourselves knock your head. Those who said 5. So you have to divide through by 4 so that you have x squared plus y squared is equal to 25 over 4. Then you have x squared plus y squared is equal to 5 over 4 squared, which is 5 over 2. Okay. Thank you. Okay, so that is it.
5 over 2.
Yeah,
5
so
over
the
2.
radius should be 5 over 2, and the center is 0.
Yeah, 5 over 2.
Yeah.
0, 0.
Thank you. The next one is how to express general equation of a circle in a standard form. Now we know that from what our brother did, he was able to express the standard form as a general solution. So he did substitution, expanded, did everything, and he was able to get the general equation. Now I want to look at when we are given it in a general equation form. How do we get it in the standard form? So considering the general equation of a circle, x squared plus y squared plus 2gs plus 2fy plus c equal to 0. We will rearrange this to get x squared plus y squared plus 2gx plus 2fy is equal to -2. Then we'll use completing of square. Do you remember completing of squares?
Yes, please.
So completing
Yes,
of squares.
madam.
By completing of squares, we know that we'll group the x's. So we have x plus 2gx. Then we'll divide this one by 2 and we'll square it. So we have plus g squared plus, so we have plus g squared minus g squared. But I'll take the -1 to the other side of the square root, so I'm going to get this. Then I have y squared plus 2fy plus y squared minus y squared. So I'll take the minus plus f squared, and I'll take the minus f squared to the other side of the square root. So that's what I have here. Then what I have here, f squared plus 2gs plus g squared, I can write this as s plus g all squared. So please, you take your time and look at this. Then plus my y squared plus 2fy plus f squared can also be written as y plus f all squared. And this is equal to g squared plus f squared minus c. Okay. But remember that the whole of this is my r. So in place of this, in place of the whole of this, I will write r squared. Okay. So I'm going to get s squared, x plus g all squared plus y plus f all squared is equal to r squared, which is the standard form of the equation of a circle with center negative g negative f and radius g squared plus f squared minus c. So that is it. So in the standard form, you just rewrite, you apply completing of squares and everything, then you get that. It says that find the center and the radius of a circle, of the circle. So I hope you can find the center. So the first of all, complete the square of this equation. So here I want to use the completing of. I know that you can just use the f and g method and then solve it. But here I want to use completing of squares. So this thing can be written as x squared minus 2x. Then I will divide the coefficient. I'll divide this one by 2, which will give me 1. So I have the completing of squares, -1 squared, and then minus 1 squared. So 1 will go to the other side. So I have s squared minus 2s plus something plus y squared minus 4y plus something plus -11 equal to 0. So this is the same as s squared minus 2s plus -1 squared plus y squared minus 4y plus, so the 2 divided by 2 minus 4 divided by 2 is my -2. So -2 squared minus 11. Then as I said, I will add the -1 here and then add it to the, so I'll do same, I'll add -1 squared to the right and add -1 to the left. So that's what I did. So I have -1 squared plus the -2 squared also here. Then I simplify. S squared minus 2x plus -1 squared can be written as x minus 1 all squared plus, and then this expression here, y squared minus 4y plus -2 squared can be written as y minus 2 all squared. And I still have my minus. -1 squared is 1, -2 squared is 4.
So I have x minus 1 squared plus y minus 2 squared is equal to 5 plus 11. So x minus 1 squared plus y minus 2 squared is equal to okay, bye. So this is equal to 16. And this is the same as x squared minus 1 all squared plus y minus 2 all squared is equal to 4 squared. So what is the center and what is the radius from here? From here, what is the center and what is the radius?
Madam, our center is 1, 2, and our radius is 4.
Thank you very much. So our center is 1, 2, and then our radius is 4. Thank you.
Madam, please, so in this case, can't we use the other method?
I said we can use it, but because we just looked at that method, that's why we did it in this like that. So you can use the other method. Is this yes?
Yeah. Can it be a situation where you'll be restricted to use the completing method or the other method?
You don't want to learn it. I will restrict you, please.
Okay.
You don't want to learn it. You will learn it.
Okay, madam.
So I'm praying that I will not forget, so that I will restrict you.
Oh, madam, why?
I'm praying that I will not forget because I know you don't want to learn it. Okay, so the next I want to look at equation of a circle on a given diameter. Equation of a circle on a given diameter. So in this session, we will learn how to find the equation of a circle given the two endpoints of a diameter. We'll look at two methods of finding the equation of a circle given the endpoint of a diameter of a circle. So this same thing, we're going to look at two ways of doing it. Okay. So the first method is to find the center. So we learned how to find the center, right? So we know the diameter. So it means that I will have the circle like this. I'll have the circle like this. Then I have the two ends. So I have A and B. Then we know that when I have A and B, I can find the midpoints. And we know how to find the midpoints, right? And the midpoint will be the center. So I just taught you how to find the midpoint of a given line segment. So you find the midpoint, which will be your center. And then you find the length from the center to either A or B. We know that from the center to any point is the same, and that is our radius. So first you find the midpoints, then after that you find the length between A and C or between C and B. That will be the radius. Then you use x minus A squared plus y minus B squared is equal to R squared to solve. So you know that the center is, so the midpoint is x plus x1 plus x2 divided by 2.
Okay.
Daddy. This obey you no man no pacho. Never go me pacho. So please, I'm sorry. Don't touch it. So
madam, it's fine, it's fine, it's fine. It's fine.
I'm still in church. I'm still in church.
It's open.
So the center is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that is the center. Then, as I said, the radius will be the length
So the radius, as I said, you can find either AC or BC, or you can find the length for the whole AB and then you divide it by 2. So please, this is B, AB, not AC. So as I said, you can find AC or CB, or you can find the whole length for A and B and you divide it by 2. So that is the first method. So the second method, so after finding the radius and then the center, you will just substitute it into the equation of the circle and it will help you to find that. The other method is, suppose we have the points A and B with coordinates x1, y1, b2, y2 as the endpoint of the diameter. Then you find another point, let another point P, coordinate xy, be any point on the circle. Take Jen.
I'm quite careful.
I do more now, say.
My friend.
No.
My friend.
Okay, so such that the angle APB is equal to 90 degrees. Okay. So that's AP is it's perpendicular to BP. So my AP is perpendicular to BP. So the product of the gradients of the two perpendicular lines, we know that. So we just learned about the relationship between two perpendicular lines. It said that the product of their gradients is equal to -1. Okay. So we will have y minus y1 over x minus x1 times y minus y2 over x minus x2 is equal to -1. So when you multiply and simplify, it will also give you the equation of the circle. Okay. So you multiply, you simplify, and you see that you're going to get equation of the circle. Don't touch it. So you simplify, you're going to get the general equation of the circle. We have an example here. We want to find the general equation of the circle, which has the line segments from A. So I have A and B as the endpoints. We have A -4, 3, and then B 2, 1 as the endpoints. Please, can you help me find the equation of the circle? Okay, so I have two groups here. I have the UCC group, and then I also have the online group. UCC group. Who is the course rep for the UCC group? Please, who is the course rep for the UCC group?
5 o'clock.
Hello?
Yeah.
Madam, please, I think we are all online students.
Online students. Oh, okay. I want some people to, okay, so I want some people to use the first method where you find the midpoint, you will find the length AC, that is the radius. Then you substitute it into the standard equation of a circle to expand and get the equation of the circle. Then I will want another group to use the other method where you find a point P on the circle. Then you will use the other method, y minus y1 over x minus x1 times something is equal to -1 to get it. Now because, okay, so I can see some names here. So let me share it. Purity, Okay, Boateng, Samuel Boateng. I can see Samuel Boateng. I can see Clements. I can see Jeremiah. Okay, so let me see. Okay, so I will mention some names. So Abdullah Kwame, Abu Bakar, Marwan, Abudu, Adam Mamusa, Edu Prince, is it Akuka Joseph, Atasinia, Ata Abdul Hafiz. Okay, so the
Madam, you
name,
need the audio.
the names that I've mentioned so far, you will use the first method. And then the rest. Okay, so Sami to his part. Boateng, Sami, Ben. You use the first method. Then the rest of you will use the second method. So Sami, Boateng, and Benis, you will be the leader for the first group. And then Dorcas Boateng, Eric Ahen, Erica Enifu. You will be the head, you'll be the leaders for the second group. So I'm giving you 10 minutes. Please solve the question. Hey, solve this question for me. Find the general equation of the circle, which has the line segments from A, -4,3 to B, 2,1 as endpoints of the diameter, please. So
Sir,
I've mentioned.
Madam, the question is not, don't zoom it. Madam, you have zoomed it so we can't see.
Don't worry. It's okay now. You can see it now.
Yes, sir, Madam.
Okay, so I'm giving
Dorcas
you how many?
Boateng and Samuel Boateng, the husband and wife.
Don't worry, they will do it.
Hey,
So,
my friend, I beg.
so please, I'm giving you how many minutes? 10 minutes. 10 is okay.
minutes.
10 minutes. So by 2:56, you're done with it. So start work now.
Oh, Madam, the question, we didn't write it too.
I want to mute myself. I will go to the question again. Let me mute myself.
Okay.
Derek, which one are we solving? Are we using method 1 or method 2?
Method 1.
We are using method 1.
Benis and Co. Method 1.
Then Eric, Eric, where are you?
We are using the second method 2.
Hey,
What
Dorcas, you're using method 1. Dorcas, you're using method 1.
what about we that they didn't mention our name?
You are using method 2.
Then you are spectators. So sit down and watch us.
Okay, we are
Which one
watching.
am I using? We are using which one?
Those names
Sammy.
that are not mentioned, they are using group 2. They are using method 2, sorry.
Sammy.
Yes.
Please, which one are you solving?
I'm using the second method.
So we are using method 1. Eh?
Yes. So you find the midpoint of AB.
Oh, okay.
Charlie, are you not done?
Charlie,
Yeah,
any
I'm
better?
done.
Oh.
I'm done with that. Akra.
Any better? Wow.
I
Yeah,
said
you.
I'm done with that. My way did that. Akra.
Aha, Sanya, you. Good.
So I'm trying to use the first method.
Yeah, I think you go.
I'm done. Oh. I'm done. Stop.
Okay, good. It's good that you are done. Someone is driving. Who is that? Is the person driving? Okay, so leader for method one. Who is the leader for method one?
Mr. Watson somewhere.
You people, why?
Mr.
You people, why?
You can tell us the solution. How did you go about it?
Okay, madam, please. So we were tasked to use the second method.
Okay. Is it group one? You use the second method. Okay.
No, is it not first?
No, the second method.
It's in the first method. What did you use the second method?
Using the first method. Oh.
We are using the second method. Oh.
Okay, you tell me how you went about it.
Madam, so for using the second method, you know that we expand using the perpendicular gradient. That's y minus y1 on x minus x1, multiplying y minus y2 on x minus s2 equal to -1.
Okay.
All right. So when you expand that one, you get y minus y1 in brackets, multiplying another bracket y minus y2.
Okay.
Plus x minus x1 in one bracket, multiply another bracket x minus s2 equal to 0. All right, so we know that for point A, -4 and 3, -4 is x1 and 3 is y1.
Okay.
And for point B, 2 is for x2 and 1 is for y2.
Okay.
All right, so when you substitute in the values, you get y minus 3 in one bracket, multiplying y minus 1 in another bracket, plus x minus 4 in one bracket, multiplying x minus 2 in another bracket equal to 0.
Okay.
All right, so when you expand, you get y squared minus 4y plus 3 plus x squared minus 2x plus 4x minus 8 equal to 0. Hello, madam. So in this case, we are going to group like terms.
Hello.
Yeah, madam.
I'm listening.
I said.
Are you done?
Yeah, I said. No, I'm not. I said in this case, we are going to group like terms.
Okay.
So after grouping the like terms, our final answer will be x squared plus y squared plus 2x minus 4y minus 5 equal to 0.
Okay.
Thank you, madam.
Thank you very much, Mr. Martin. Thank you too. So,
Well done.
Sorry, please mention your answer again.
okay, so somebody is asking you to mention their answer again.
I said you get x squared plus y squared plus 2x minus 4y minus 5 equal to 0.
Okay, thank you very much. So please, someone should write it somewhere. Then who is the leader for
Please,
the first one?
please, madam, my answer differ from this answer.
Your answer is different. You put it down. Let's look at another person's answer. Group one. Who is the leader for group one?
Jeremiah, please mute yourself.
Group one. Method one.
Hello.
Any volunteer for method one?
Dorcas, where are you? Dorcas, where are you?
Madam,
Uh-huh.
Madam, we found midpoint. So the midpoint.
Oh,
Okay, yeah.
The points are negative. After finding the midpoints, we got -1 and 2. Then we find the length of the radius. So we took the A coordinates and the center, the point A and the center, the midpoint rather, which is -4 and -3 as the point A and -1 and 2 as the as the midpoint. Then we found the distance, the radius, getting the radius to be root 10. So after that, we used the standard form, which is r square is equal to x plus 1 all into bracket squared plus y minus 2 all in bracket squared. So after expanding it, madam, we got x squared plus y squared plus 2x minus 4y minus 5 is equal to 0.
Is it the same as Mr. Watson's solution?
Yes, madam.
Okay. Thank you very much. Then let's look at what I also have.
Madam,
any question?
Madam, I use some formula. I use a vector method, but I still got the same answer.
You use which method?
I use what I call a assume point, and which have to do with vectors. Find the vectors of vector of a perpendicular.
Hey, please, we are too young. We are young, why?
Sharks in the building. Hey.
We are young.
Please, madam, can we go through my step? My answer is different from what all of you are having.
Okay, so we'll go through my steps. Okay, then we'll see where you went wrong. Huh? So that's my method. So the first method, you have to find a midpoint. So the midpoint will be -4 plus 2 over 2. And then 3 plus 1 over 2, which will be -1. And then positive.
Please,
2.
Jeremiah, please mute yourself. Jeremiah, mute yourself.
Then after that, you have to find the radius. So either AC or CB or AB divided by 2. I mean the distance divided by 2. So if you choose AC, then that will be -4 plus 1 squared plus 3 minus 2 squared. And my R will be square root of 10. So using R squared is equal to x minus A squared plus y minus B squared. I will do the substitution. I'm going to get square root of 10 squared is equal to x plus 1 squared plus y minus 2 squared. So after expansion and simplification, you're going to get x squared plus y squared plus 2x minus 4y minus 5 is equal to 0. So if you
Daniel, mute yourself. Daniel.
If you didn't get that, then maybe you have to look at your solution again. Or the other method, as Mr. Boateng gave us, you let P with coordinates x, y be any point on the circumference of the circle. Then the gradient of AB will be equal to y minus 3 over x plus 4. And the gradient of BP will be y minus 1 over x minus 2. So we know that when you multiply the 2, you are supposed to get -1. So we have y minus 3 over x plus 4 times y minus 1 over x minus 2 is equal to -1. So when you expand, you simplify, you're going to get x squared plus y squared plus 2x minus 4y minus 5 equal to 0, which is the same as using the first method. So the one who didn't get the same solution, please, you have to look at it again.
All right,
So
madam, hello, madam. Let's look at where you have y minus 3 multiplying y minus 1. Please, let me use your slice.
Y minus 3 multiplying y
Yes, the top
minus
there.
1. It's
All over x plus 4 multiplying x minus 2 equal to -1. So that place, the -1 is also dividing by 1. Now, when you come to your next step, the -1 didn't apply to the step that you have.
okay. So this means that when I cross multiply, I'll have y minus 3, y minus 1 is equal to minus the bracket x plus 4 x minus 2. Then the minus it will come to the other side and it will become negative. It will become positive. That's why I have x plus 4 x minus 2 plus y minus 3 y minus 1 equal to 0.
Okay,
because
so
the down part the negative. Then when it crosses to the other side, it will become positive.
Madam, where we have the -1 dividing by 1, shouldn't we do cross multiplication at the top there before we now expand?
You do cross multiplication, but cross multiplication and then bringing it to the other
Before
side,
we
the
expand.
x component will still become positive.
Wow. Because I actually had x squared plus y squared minus 2x minus 4y minus 5, all equal to 0.
When you do it, what he's saying, you get the same answer. If you do cross multiplication, and you simplify, you still get the same answer.
You should get the same answer. So please take your time and then solve it again. Is that okay?
I'll do just that.
Okay, thank you. Okay, so the next I want to look at equation of a circle through 3 points. Through 3 points. So in this session, we'll discuss how to find the equation of a circle through 3 points. So this one will have different methods, but the method 1, we want to look at the steps. So the method 1, first you assume the equation of the circle is x squared plus y squared plus 2gs plus 2fy plus c equal to 0. So first you assume that is the equation of the circle. Then second step, you substitute the 3 points into the equation in terms. So first you substitute the first one. So the coordinates for P1, you substitute, you simplify, you put it down, you call it equation 1. Then you substitute P2. You substitute it into the equation, you simplify, you call it equation 2. You substitute P3, the third point, you simplify, you call it equation 3. Then after that, you see that you will get 3 equations with 3 unknown values, that is G, F, and C. You will get 3 equations with 3 unknown values, G, F, and C. Then you have to solve for your G, F, and C using any method that you know. You solve simultaneously by elimination, by substitution, by any method. So your aim is to get the value of F, G, and C. Then after getting your F, G, and C, you go back and substitute them into S squared plus Y squared plus 2GS plus 2FY plus C equal to 0. And that is the equation of your circle. So that is it. That's the first method. Good afternoon. Good afternoon.
Okay. How for you? Yeah. I don't know. Last year the boys one coming up on count.
You can come for. You shall come for Aduma.
Echo. Echo.
So the second method.
Okay.
But it does not screen now.
From the center, you know the center. So that from the center, you can find the bisect, a line that divides the P1 2. So the bisector, and then you have a line that divides in P3, the bisector. Okay. So the steps, you find the equation of the perpendicular bisector, M and N of the chords P1.
Madam,
P2.
please, I cannot see the
So
board.
that's the chord P1, P2.
Madam, please, we can't see the board.
Can the rest see?
The board has come.
All of you.
It has
It
come.
has gone again.
Now.
No, please. We can't see your screen. No, please.
Hello. Sorry. Please, can you see now?
No, madam, please, we cannot see.
Hello.
Hello.
Yes, madam.
Yeah, madam, yeah,
Madam,
I
we
cannot see.
Hello.
Yeah, at my side, I cannot see
madam,
the
we can
board.
see now.
Hey,
We can see
where's
now.
my phone?
Yeah, madam, it's showing. It's showing
We
now.
can see now. We can see
Yeah,
now.
it's now showing.
Oh. They've taken my phone to the room. And
It is not showing at my end here.
Maybe that's
The
why.
same thing. It's not also
Then
showing at my end.
Then check. It is from your network. Check. It is from your network.
I'm at MTN Central, so I'm not getting it.
Brony Frudia.
Hey.
Madam, we can see your screen. Yeah.
Okay. So as I was saying, I have the code one P2 and then the code P2, P3. So we want to find the bisector of P1 and P2. And then we find the equation of the bisector P2 and P3. So it says that find the equation M of the focus center. So in the center. So equation simultaneously. So the equation for the bisector M and N. Then when you solve the simultaneously, thank you. The distance to P1, P3. So from C to from R to NSA plus B. No, there is only one point P1.
The network is worrying now.
The screen is no more coming, madam.
Is that?
Please check your net. It's not
Okay.
everyone.
Don't worry. It has left with only 13 minutes, so manage it like that.
Can you? See?
No, madam. No, madam.
Hello?
It's not coming. It's only what
Madam, we can see. We can see.
Yes, I can see.
Madam, we can't see you.
Here too. Here too.
Let this one example, then we'll close. Let's solve close it, please. Okay. Hello. Hello. Hello.
Hi, madam.
Yes,
Madam.
Madam.
Hey. Yes. Can I continue?
Yeah,
The
you can
network
continue.
is
We can hear you
breaking.
and see your screen.
You and who can see this?
And the network in my house is very bad.
Hey, calm down now.
Let's make it another time.
No problem. We can end now. We can end here and continue next
Madam,
week. Okay.
Madam, it has left with 10 minutes. So it has left with 10 minutes.
Madam, please.
Madam, let's finish.
Madam, yampon.
Madam, I got 10 minutes in 10
It's now
pounds.
clear.
Right.
Let's finish up. Be patient.
Okay. So there's a question. We are to find the equation of the circle. And it has the points P, Q, and R on the circle. So we want to find the equation of the circle. Okay. So here we are given 3 points on the circumference of the circle. So
Group
using
leader,
the
help
method
us.
1, hello.
Yes,
Hello.
madam.
Yes, madam. We can
Madam.
hear you.
Yes, madam.
No, we can hear you.
Okay, so we have the points P, Q, and R on the circle S. So using the first method, we will let the equation of the circle be S squared plus Y squared plus 2GS plus 2FY plus C equal to 0. Then it says that we have to substitute the points into the equation of the circle in terms. So first I'll substitute my P, which is -4 and 2. We know that the -4 and 2 are the X and Y values. So I'll substitute X equal to 4, Y is equal to 2 into the equation S squared plus Y squared plus 2GS plus 2FY plus C equal to 0. And this will give me -4 squared plus 2 squared plus 2G times -4 plus 2F times 2 plus C equal to 0. When I simplify, I'm going to get 8G minus 4F minus C equal to 0. Then I will also substitute Q, which is -2, 6 into the equation. So I'm going to get -2 squared plus 6 squared plus 2J times -2 plus 2F times 6 plus C equal to 0. And when I simplify, I'm going to get 4J minus 12F minus C equal to 40. Then the next one, I will substitute R, which is 4/8. And this is 4 squared plus 8 squared plus 2J times 4 plus 2F times 8 plus C equal to 0. Okay. And then simplifying and solving. So we have to solve using any method. Do you have 3 equations? Okay. So I'm solving. Say we now solve between equation 8, 9, and 10 simultaneously. So any method, subtracting equation 9, 8, and 9, this will give you -4J minus 8F is equal to 20. Okay. So dividing through by 4, I'm going to get J plus 2F is equal to -5. I can call it equation 11. Then I will subtract equation 8 and then 10. And this will give me 12J minus 4F is equal to 40. I divide through by 4 and it will give me -3J minus F is equal to 10. So you know how to solve simultaneous equation. So making F the subject, I'm going to get -10 minus 2G. Okay. Then substituting F equal to -10 minus 3G into equation 11, I'm going to get 2 plus J plus 2 into brackets -10 minus 3G equal to -5. I simplify and I'm going to get my J to be -3. Okay, I think even my laptop is going off. I have low battery. Okay, so please, I think my laptop is going off. So you can just try and solve, and you're going to get 3 values. You're going to get your F to be -1, your C to be -40, your J to be -3. And then when you go back and write your S squared plus Y squared plus 2G S plus 2FY plus C equal to 0, you make substitution and you're going to get S squared plus 2 S squared plus Y squared plus 2 times -3 S plus 2 times -1 Y plus -40 equal to 0, and the equation will be S squared plus Y squared minus 6S minus 2Y minus 40 equal to 0. That is the equation of the circle. Because of my network, I want to end here. We can, and then the
laptop,
my battery,
and the laptop.
Yeah, and the laptop will end here.
Battery
And then when we meet, when we meet next time, we'll look at the alternative approach and solve all. But you can also, I wish I can take the slide, the solution to that solution off.
But you can also try the alternative approach. Then when we meet next time, we'll all discuss. Okay, so end here. Thank you very much. I can see a
Thank you,
hand
madam.
off.
Thank you, madam. Thank you, madam.
Madam,
I can see a
your
hand
laptop
off.
going off still.
Yes, madam.
Yeah.
Sheriff, put down your hand.
Eric, your hand is off. Your hand is up.
Oh, madam.
Sheriff, lower your arms, please.
Everybody.
Sheriff, I'm listening.
Lower your hand.
No,
Okay.
let's him ask the question.
Oh, I just want to find out, in case you substitute the points into the equation and you now have a simultaneous equation, like the approaches in solving the simultaneous, can you just use calculator to find the F, G, and T without solving it?
No shortcut to heaven.
Exam session, I have to see it. If it is just objective question, then you can use it later.
Okay, thank you very much.
You're welcome.
My hand is apple. My hand is apple.
And then there's another hand up. Yeah, ask your question.
Hello, madam.
Yes, Jeremiah.
Madam, please, I'm Mohammed.
Mohammed.
Did you raise your hand?
I can see Jeremiah's hand.
This is the first time I'm joining your session, and
okay.
I must say your explanation and how you are handling the class is really exciting and interesting. And
oh, my brother, did you raise your hand? Allow me to finish first. Hello, madam.
Yes, dear Mohammed.
Master, your class 5.
I want you to get
your class 5. Madam, thank you.
Madam.
We shall meet again.
Hello.
So, madam, please, I want to, if you can get us a past question, that's number 1. Number 2, madam, how are you feeling now? Because the last time you were not feeling fine. So, how are you feeling now?
I went to the hospital yesterday, and I think today I'm better.
Oh, thank you. We thank God. That's all I have to say.
Thank you too. Jeremiah too, your hand is up. Daniel.
Madam, your laptop go
please,
off.
the slide.
It's okay. Let madam go and rest. It's okay. It's okay.
I will share it, but not today. I want you to solve the question I gave you. Then when we meet next time, you give me the solution. Then I'll share the slides with you.
Madam, I think your laptop is off.
So I can even share the second one with you, but I'll not share it. Okay, so let me answer Daniel and Kwame. Kwame Opoku Ofori. Okay, your hand is down. Daniel, to your hand is down. Okay, so let's end now.
It's Opoku Ofori. It's a Kwame Opoku. Freshman.
Okay, madam. Thank you.
Thank you too. So, Hey, Richard.
Mr. Richard, I beg. Mr. Richard, it's okay. It's okay.
No, I hear.
Yeah, Rich. We have 2 minutes. You can talk. And Mr. Boateng. Rich first.
Madam, the thing is, your laptop will go off. So, madam, please, you can leave us. We are okay.
Madam, please go and rest. Madam, please go and rest.
I hear.
You need to rest.
You write down all your questions. When we meet next time, we'll discuss it. Thank you very much, and enjoy the rest of the day.
Enjoy your Sunday.
Thank you too, madam. God bless you.
God bless you too. Bye bye.
Any food for the boys?
Madam.
Food for the boys. I'll give you food later. Don't worry.
Madam, you want
madam,
to see your face?
I will come home.
You'll see my face one day. Don't worry.
It's okay.
On the background, you'll be seeing my face.
Madam Bato.
I hear. Thank you. Bye bye.
Bye,
madam. Bye, madam.
Please, course rep, madam class in the 5 in the course rep.
Yeah, some
Charlie, I know
more
you.
2 lessons. So you better send 5 o'clock.
I know
Madam, I cost you bit my baby for one my
So wait till they share weekdays in here.
Most madam mama. It's a way 5 for no so called boy.
I'm very if you don't pay bindi you.
Me phone could do.
Charlie, Fred, and I say, obey him, they
Na
share.
no me can no na e phone tema me share me mama yen share. Na na e be phone.
It's okay. Go and rest.
It's a
Go and
na
rest.
ni pa mi be ye de na ben.
Me
One
phone
thing
call.
only, I'm friend madam na mum pedal for.
No me can say you must say isa say switch into the ben na switch and
Switch no